That's not the one we did. That one's the one we did. Okay. All right, here we go. So there were some tricks in this. So in the one we were looking at, you've got the graph of f. They do not tell you what g is. I thought this was pretty confusing. I actually had to play with it for a little bit myself. I don't know that I've seen one written this way. Anyways, so part A was easy. I'm talking about part B. I'm getting ahead of myself. So for part A, x coordinates of the points of inflection for g. So what do we know about this? So for A, what do we know? We're looking for points of inflection for g, and we know that g is equal to integral f. So now here's the only thing. While I know what you're talking about there, we don't want to write it that way. We got to get very specific. It's g of x is equal to the integral of f of t dt. Okay, so that we know that, so that when we take its derivative, we can say g prime of x is equal to f of x. All right, so now that we've led with that, you can make the assumption that you're looking at the graph of g prime. So we've been doing this with derivative graphs all year. I have a derivative graph, and I want to find its pointer points of inflection. So how do we do that? It's the turning points of the derivative graph. So I see 3 turning points. I see one at 0, 1, and at 3. So at x equals 0 and 3, because g prime of x changes from, what are we changing from in this one? They're both decreasing to increasing. And at x equals 1, because g prime of x changes from increasing to decreasing. So does anybody have any questions on the first one? Okay. All right. Next
question. This isn't like about the math. This is just about like the AP exam in general. If you miss one, like if you got, I don't know, like if you got 2 but you forgot to put 1, with how much credit would you get? Would you get no credit, partial credit?
It should be partial credit. Yeah, everything is partial credit. I would expect you. It's hard to say on any given question what is worth what, but they definitely give partial credit out everywhere they can.
Okay.
All right. Looking at part B, I thought this one was a little crazy in the way that it was written. Usually they just tell you the function of what we got. So in this one, we want the minimum value. So first off, they're talking about absolute. Sorry, give me 1 second. My doorbell just rang. All right, let's start that from scratch again. Sorry about that. All right, find the minimum value. So we are talking about the absolute minimum value because it doesn't say one way or the other. So if it doesn't tell you something about relative or absolute, you're going to assume we're talking about an absolute minimum. So to find an absolute minimum, this is the problem where you're making an XY table and we're putting endpoints and critical points onto this table and comparing our Y values. So first things first, we've got -4 and we've got 7. Those are the endpoints. And now we need the critical points. The critical points for what graph? G. What do we already know about G? G is equal to integral F. So since G is equal to integral F, we know that G prime of X is equal to F of X from last problem. So if I'm looking for where G is, G prime is 0, what are we going to get for this? We want to know where F is 0. So F is 0 in 3 spots. This is like the same thing as saying where it touches the x-axis. So there's really 3 spots. One of them is the endpoint that's already listed. One of them is at 1, and the other one is at 5. Now, we're trying to find a minimum. So as of right now, I'm evaluating this as if it's the derivative. So if this is the graph of the derivative, is it possible that I have a minimum value at 1? Why or why not?
This minimum value isn't it like the Y coordinate, the minimum value for
Yeah, you're not thinking about what I'm saying now. So I'm telling you, like, if we have, here's the graph of the derivative. There we go. There's the graph of the derivative. That's the graph of F prime of X. And I want to know about relative min and relative max. Where's the relative min at?
Is there no relative minimum because it doesn't cross the x-axis?
Okay, yes. So what I was getting at is for it to be a relative min or max, it's got to cross the x-axis straight of your derivative graph. Like this one changes from below to above. That could be a min. This one changes from above to below. That one could be a max. So in terms of the problem we're talking about, we're doing endpoints and critical points into the original. So I've got the endpoints. Now to find the critical points, we're looking for where is G prime going to be equal to F equal to 0. It's going to be at the 3 spots where it's 0, but only in one of those places does it cross the axis. So the only one we need to put on the table is at 5. Okay. So it's endpoints and it's critical points into the original. So here comes the fun part now. What's the original? What do we know about G? G is equal to integral F. But we need a little more than that. So let's start with that. G is equal to integral F. So it's integral of F of t dt. But now I need to plug into this stuff, right? What am I plugging into G? I got to plug in this one and this one and this one, and I got to see what's going on. So I need bounds to plug into. What am I plugging into here? So that's where this piece comes into play here. It says that G of 1 is equal to 4. And that makes this a bit of a mess. In other words, if I do this for my bounds, 1 to x, right? 1 to x. What happens when I plug in 1? What would G of 1 be?
4.
But I don't have that represented yet in my function. I'm just saying, based on the function you see here, what would happen if I plug in G of 1? What's that going to give me?
It wouldn't be anything, it would just be 0.
It'd be 0, right? But what's it supposed to be?
4.
Yeah, so we got to alter our function a little bit and say that G of 1 is equal to F of t and then plus 4. That makes it a true statement. So you got to alter this entirely. And we say that G of 1 is now, does that make sense now that I'm showing it to be 4?
Yes.
Hopefully, maybe. All right, so now we got to look up 3 things. I got to look up G of -4, G of 5, G of 7. So we're going to do G of -4. So G of -4 is equal to 1 to -4. Those are backwards, first off. F of t dt plus 4. So what is the area from 1 to -4? From 1 to -4, we're going the wrong direction here, by the way, right? So that's an area of 10 cut in half, it's 5. Underneath is -5. But since my bounds are flipped around here, what are we coming up with in that particular case?
It's a negative.
Is it going to be a negative? So we're doing -4. So at -4, we're looking at from 1 to 4. So 1 to -4, that's 5 by 2 is 10, cut in half is 5. It's underneath the axis, but what do I need to do with this? I need to flip these around, toss a negative sign out front. So F of t dt plus 4. So -4 to 1, that's going to be -5. That makes it +5. We on board with that being 9?
Yeah.
Okay, let's do it again with 5 and then with 7. So if we go for 5, G of 5, that's going to be the integral from 1 to 5 F of t dt plus 4. So from 1 to 5, 1, 2, 3, 4, 5, this is your semicircle and it's underneath, so it's going to be a negative area. The radius of this circle is 2. So that makes the area of that whole circle, if we had a whole circle, 4 pi. Means the area of a semicircle is 2 pi. The area is underground, so we make it negative. And then I tack on 4. So this is going to be 4 minus 2 pi. And then we do the same story again with 7. See what we get with 7. You guys try 7, see what you get. Find me G of 7, go. Find G of 7. Anybody got it? What do we get for G of 7?
2.
We're going to incorporate the circle, right? There's got to be something with pi, isn't it? G of 7
Oh,
is going to be the integral from 1 to 7. What do we get from 1 to 7? We already know 1 to 5 is negative 2 pi. And then, so it's, we know 1 to 5 is negative 2 pi. And then 5 to 7 is positive 2. So it's negative 2 pi plus 2 plus 4. I'm coming up with 6 minus 2 pi. Okay. So then when you look at these y values, what's the smallest y value, guys?
Nine.
Is 9 smaller than 4 minus 2 pi?
No, it's 4 minus 2 pi.
There we go. Yeah. So just think of pi as the number 3, even though it's not. Just think of it as 3.14. But for the sake of estimating what we got here, this is like saying 4 minus 6. That's going to be your smallest number. So we have an absolute minimum at y equals 4 minus 2 pi when x equals 5. I think I was pretty confused, not gonna lie. I think them not giving you the function makes this pretty tricky. More times than not, you're given the function, the one that we had to kind of come up with on the fly there. Okay. Questions, thoughts, what do we think?
When does it say that g of x is equal to the like?
Right here, the function g not shown is the antiderivative of f. So is means equals. So this is like saying g is antiderivative is a synonym for integral. So g is integral f.
Okay, thank you.
And then this piece right here was how we were able to play around with this and figure out that it was really f of t dt plus 4 to balance it out. And then we could go from there. Okay. All right. So the good news is that I think it gets a little smoother after that, hopefully. So let's see what we got. In part C, we have a function h, and we're looking for h prime and h double prime. So h is equal to, that box is always in the most inconvenient spot that pops up here. H is equal to 3x minus 1 to 2x f of t dt. Okay, so first things first, we want to find h prime. So h prime of t is equal to 3 minus f of 2x times 2. Does anybody have any questions on that derivative? Okay, and then we want to put in -1. So h prime of -1 is 3 minus f of -2 times 2. So we need to figure out f of -2. That's up here. So to get to that spot, I mean, you can kind of clearly see it's -1, but we can prove it to ourselves knowing that the slope of this line is -2, right? So that's down, I'm sorry, it's -1/2, down 1 over 2, down 1 over 2. So by counting that out, you can just say down 1 over 2. So f of -2 is -1. So now that's 3 minus -1 times 2. That's really 3 plus 2. I'm coming up with 5. Okay, and then we need to do h double prime. So h double prime of t is equal to, the 3 is gone. And then, so in reality, let's think of this function. Let's clean up h prime. H prime is equal to 3 minus 2 f of 2x. That's what we're taking the derivative of. So the 3 is gone. And then it's trig prime, so -2 f prime, trig prime, stuff prime. And then we can clean that up and call it -4 f prime of 2x. And it wants us to find h double prime of -1. So that's -4 f prime of -2. So what is f prime of -2? It's the slope of that line. And we just said the slope of that line is -1/2. So that's -4 times -1/2. And then that answer is 2. Any questions on part C? Okay, moving on to part D. Let K be the function defined above. Is K continuous? So first thing we're going to try is we're just going to plug in 0 for both of these and see what we get. So what do we need for something to be continuous? How many rules are there?
3.
3 of them, right? All right, so let's just start by getting an idea. What happens if I plug, I'm not even listing any rules yet. I'm trying to get a sense for what's going on. Let's plug in our 0. So this is f of 3. If I plug 0 into the top, f of 3, and the bottom is f of 3, right? Because that's 3 minus 0 minus 0. Aren't those both going to be f of 3, right? So there's the same exact thing for the top and the bottom when I put in 0. So sounds pretty good to me. It's got to be the same thing, right? It's 0 if you're getting the same spot. So
Wait,
for
the bottom shouldn't that be if?
there's f of 0. Yeah, what am I doing? Hold on. That sounded way too easy. You're right. How about f of 0? So I get for getting carried away there. All right, so what is f of 3? F of 3, 1, 2, 3 is negative 2. And f of 0 is also negative 2, right? All right, so those are going to match. That's negative 2. That's negative 2. And we've got it. Sorry, I'm trying to get him to calm down here so you guys can hear me. All right, so if something's going to be continuous, we need 3 rules. And the first rule is that the function is defined. So we can say that the function is defined at where the spot we're interested in is 0, right? At x equals 0. And then my explanation for that would just be showing the math we just did, showing that f of 3 is negative. F of 0 being plugged into both of them basically gives you a value that exists. So we would show f of 3 minus 0. That's really f of 3 is negative 2. And then f of 0 is negative 2. Function's defined. The next thing you need to show is that the limit exists. So we're going to be getting negative 2 a whole lot here. The second rule is the limit as x approaches 0 from the left is equal to the limit as x approaches 0 from the right. And that in both cases is negative 2. And the last rule you need to show is that the limit as x approaches 0 is equal to f of 0. And that is also negative 2. So in all circumstances, you have shown without a shadow of a doubt, this function would be continuous. Any questions there?
Can you zoom out?
For the justification, can you only say that the function is continuous at x equals 0 because all the conditions of continuity are met?
Say that one more time.
Can we just say that the function is continuous at x equals 0 because all the conditions of continuity are met?
No, definitely can't do that. They're gonna want you to list them.
Okay.
All right, we got one more part to look at. So I think this one wasn't too bad, right? So what are we talking about? We've done speeding up and slowing down. For speeding up and slowing down, we need to compare V of t and A of t. So it tells us that V of t is equal to F of t. So let's just start right there and figure out what are we talking about here. This one. Try to get it away from that window. Okay, the velocity of the particle is modeled by that. we're looking for everything about t equals 1/2. So I'm looking for velocity at 1/2. And the velocity at 1/2 is the same thing as f of 1/2. And I remember, I don't need to know exactly what it is, but f of 1/2 is a negative value. Okay? And then to find a, we take the derivative of v. So a at t is equal to f prime of t. So a of 1/2 is equal to f prime of 1/2. What do we know about f prime of 1/2? F prime of 1/2 is the slope of that line, and the slope of that line is positive. So now we've got one of each, and that would give us the slowing down verdict. So it's slowing down at t equals 1/2 because v of 1/2 is less than 0 and a of 1/2 is greater than 0. Pretty complicated problem, in my opinion. That's a lot of tricks and turns and twists. And what do you think, those? Most of that makes sense after having seen it?
Except for B, everything else was easy.
Fair. All right. I can settle for that. So I don't know that I've ever seen one written quite like B, to be honest with you. So how I've always seen B written, because truthfully, when I went through and did this the other day, I was pausing as well on part B, saying, what are they saying here? Usually in the directions of the problem, it would just tell you, and by the way, g of x is equal to 1 to x f of t dt. That is just given to you. So if that's given to you, then the problem is easy, in my opinion, right? So let's just pretend that they give this to you. Hopefully that's the case. If that's given to you and you're asked to find that absolute minimum value, that's when we make a table and we say endpoints and critical points go into the original. Okay, how do I find a critical point for g? I take the derivative and set it to 0. So in other words, I'm wanting to know where is g prime equal to 0. Well, we don't have much information on g, but we know that g is equal to integral f. So g prime being 0 is the same thing as f being 0. And then f being 0, you had a graph that looked like this. F being 0 is going to happen here and here and here. And then I was saying, all right, since we're treating this as a derivative graph, for it to be any kind of max or min, it's got to cross the axes. And the only spot where that happened at was 5. So I only threw 5 on my table. You could throw 1 on your table if you want to. It's just, I know for sure that's not going to be the answer. It can't be a max or min if it's not crossing. And then after that, you just take these values and you plug them into the function that they should have given you. And then you're home free after that. Any other questions, comments, thoughts? All right, so today is Wednesday. I don't really have anything to teach you guys tomorrow, so I am going to really even turning my webcam on to say hi, really suggest that you do the mock exam over spring break. And so I will even take tomorrow night off for you guys, so you don't have to do anything tomorrow. But take the 4 hours necessary, and we're moving, by the way, in case you wondered why there's 10,000 boxes behind me. And take the 4 hours necessary over spring break and work through this exam. So you can text me all your questions over spring break. I'll get back to you. It should take you about 4 hours to do the whole exam. So when you're done, you should have a list of 30 answers, 30 answers for multiple choice, another 15 multiple choice, and then 6 free response. So do your best to, when you're doing it, I guess if I were you guys, I would do it 2 ways here. Let me put this back. So I would just make a straight list on a piece of paper, 1, 2, 3, down to 30, and I would record my answers. So that way you can grade it real quick, because I'm going to read you the answers because we want to get a score. So you can just record A, B, A, whatever. And then I would have each problem worked out then in your notebook, whatever. Here's problem 1, there's the work for it. Here's problem 2, here's the work for it. That way, when we're going over it, you can see what I do, what I not do, because I plan to go over every single question on that exam with you guys over that first week when we come back. So make your list somewhere, however you want to do it, so that you can quickly grade without worrying about the work. You can just check it off. Yes, 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 wrong. Yes, 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 wrong. And then after that, we're going to go through and spend a whole week going over that exam and dissecting it and figuring it out and grading it and this and that. And that is going to be a lot of what we'll be doing down the stretch. Okay. So does anybody have any questions?
The exam is on Canvas, right?
It is not up yet. I will, as soon as I turn this off, I'm going to go. I have 3 of them that I have you guys do before you take the real one. So I will go grab one of those 3 and upload it. It's like 30 pages long, something like that. So it's all in one PDF file. And then the times are written on the front of it. But just on the off chance they're not, write these down just so you know it. So for 30 questions, just scribble this somewhere in your notes so you know what you're doing. I think it's written on there though. For 30 questions, it's 60 minutes and that's without a calculator. For 45 minutes. So the next section is 15 questions, multiple choice, and that's 45 minutes. You get 3 minutes per question on those ones. And then you got 6 free responses after that. And that's 2 with a calculator, 30 minutes total, 4 without a calculator, 60 minutes. So you guys do it however you want, time it out, work through it. But it should take around 3.5 to 4 hours by the time you're done with the whole thing. So let's get that done over break. Enjoy your spring break. So there's no need to come on tomorrow. And then message me with questions over spring break for your exam. And then we will meet up in about 10 days or so. And that's where we'll pick up. Okay. Sound good? All right, guys, enjoy your break. I'll talk to you in a bit.
Thank
Thank you, Mr. Baker. Have a great break.
Thank you.
You're welcome. All right. See you guys.